How do the charge and discharge curves of FeFe-PB materials with low defects reveal the intrinsic electrochemical behavior of these materials? And in what ways do the low defect levels contribute to enhanced performance and stability during battery operation? What specific characteristics in the curves indicate how the presence of minimal structural flaws influences energy storage efficiency, and how might these observations guide us in designing materials with optimal defect levels? How do the charge and discharge curves of no-vacancy CoFe-PBA materials differ from those of materials with inherent vacancies, and in what manner does the absence of vacancies impact the overall electrochemical response, including voltage profiles and capacity retention? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? In what ways can the comparison between these two types of materials, those with low defects versus those engineered to be vacancy-free, help us understand the direct correlation between structural integrity and battery life? When examining the cycle performance of MN-Fe-PBA materials, what trends emerge over repeated charge and discharge cycles? And which factors inherent in the material's composition and structure might be responsible for any observed improvements or degradations in cycle life? How do the dynamic processes during cycling, such as ion transport and phase transitions, manifest in the performance data, and what implications do these have for the long-term stability of sodium-ion batteries? Additionally, what unique features are evident in the charge and discharge curves of VFE-PBA materials, and how do these features compare to those seen in the FeFe, CoFe, and MN-Fe systems in terms of capacity, efficiency, and reaction kinetics? How might the incorporation of vanadium, which can exhibit multiple oxidation states, further influence the electrochemical performance of the PBAs? And what potential advantages could arise from such multivalent behavior in energy storage applications? Overall, how can the integration of these varied performance data points, from low-defect FeFe-PB materials, to no-vacancy CoFe-PB materials, to MN-Fe-PBA cycle performance, and finally to VFE-PBA charge and discharge behavior, provide a comprehensive picture of how material defects, vacancy engineering, and elemental composition synergistically determine the electrochemical properties of PBAs? And in doing so, how might this understanding pave the way for the rational design of next-generation battery cathodes with enhanced performance and durability?